motion, it's revolution or rotation. We're going to broaden it when we get to simple harmonic motion to round trip. One complete round trip. Okay, the time for that. So what's the time, the period of the Earth's rotation on its axis? What's that period? How long does that take? 24 hours. What's the period of our revolution around the sun? Yeah, 365 and a quarter, something like that, days, right? So what we're going to do today is make something go around in a circle, and we're going to time how long it takes it to make, is it 50 trips?
Yes.
Okay. So that's capital T. So now if I want to know what the average speed and hence the instantaneous speed at every position of an object is, if it's going around in a circle of radius r, are we using little r or big R? Big R. It varies. Sometimes we use the little r. Okay, so here's the deal. The radius of the circle is capital R. How far does an object go in one period? Do you remember from the very first lab? What's this distance around called?
Circumference.
Circumference. And the circumference,
2 pi r.
2 pi r. So the V is equal to the circumference of the circle divided by the period. Capital T. Now, here's something important. It's capital T and not lowercase t. All right? This is not just time. This is the period. It's like a specific length of time. Okay, so in formula form, like using all letters, it would be 2 pi r over capital T. Now, this next one, I'm not even going to try to derive with you. I'm just going to tell you. You can look online and find a derivation. If you want to come see me, I'll go through a derivation. But really, the easiest way to derive it is with calculus. And you know, if you want me to show you that, I will. But what I'm going to tell you right now is that the centripetal acceleration, which we are going to label A sub c, little a sub c, centripetal, is v squared over r. You can derive this. I'm just handing it to you, okay? So if you ask me where that comes from, I'm just going to say I handed it to you. Okay, now in your data table, that acceleration is the centripetal acceleration, v squared over r. So maybe I'll come back over here. So I'm sort of filling it in backwards here. Okay, so we have A sub c. It only says A, but it's actually A sub c. And it's v squared over r. And it should be in meters per second squared, or meters per second per second. Then the next column, I think, is V. And once again, meters over seconds. And so that's going to be 2 pi r over t. So the measurements that you're going to make, two of the measurements, are the radius of the circle and the period of the revolution. Okay, so you will see capital T in two places. One is just capital T, which is going to be the T for 50 divided by 50. Okay, and then over here, you're going to time 50 revolutions. That will also be in seconds. Okay, so those are all things about the acceleration, about the motion. But what we want to do is relate the net force on the thing going in a circle to this acceleration. So the first three columns, well, actually, no. The first column is radius. So it's the M and the F that we're going to worry about to get the force. So let's see. 1, 2. Here's radius. Now, you're probably going to measure the radius in centimeters and then convert to meters. How do you convert centimeters to meters? Move the decimal 2 places to the left. Okay? So let me show you the apparatus. What you're going to do is make this is a heavy, like it's just a sinker. I think it might be called a bobber in there, but this would never bob. That would sink like a stone if you threw it in water. Now, there's a spring here, and the spring pulls that toward the center. So we're going to use that spring to provide the centripetal force. Now, the biggest danger here is getting hit in the head or the eye or something with this thing. So just watch yourself, all right? Now, and I'm going to take this little thing off here. Here's how you're going to measure the radius. There's a little plate with a post on it here, and there are 2 thumb screws, and it can slide back and forth. So when it's in this position with the post closest to the rod here, that's the smallest radius you're going to get. And then to get the biggest radius, you'll move it out here. So I'm going to go ahead and put it on the, I'll put it on the biggest radius. Here's the deal. Now this takes some physical coordination to do this. The way you're going to, this is like old school, okay? No motor here. It's human power. Ooh, I'm having trouble. Oh, it's almost, is it going over that rod? Okay, so let me tell you something before I do that. You can slide this back and forth, you know, a little bit to make it so you can have, I mean, ideally this would be vertical when it's over the rod. Okay, so whoever's in charge of this part needs to keep the sinker going in a circle at a constant rate. Of course, ooh, there I'm making it go too fast. So you just have to keep adjusting. And you want to do 50 complete trips. Okay, you with me? That, you might want to be sure this thing is on there tightly too. That's your counterbalance. It just occurred to me. I didn't check it. I just started. That could have been a disaster. Check your apparatus before you start turning stuff. Okay, so you get how you're going to measure the period, right? You with me? Okay, now here's how you're going to measure the radius.